Now, when we use electricity, we use it flying around an electric circuit. And all electric circuits have a few similar things or a few components that they have in common. So I've got an electric circuit here and it's got all the components it needs. So all electric circuits have got a power supply, and my power supply here is a battery. They also have some sort of connecting wires, so I've got a whole bunch of connecting wires here. And they also have a load. So the load is the part of the electric circuit that does the work. So the load in my electric circuit here is actually a light globe. So when electricity flows through this globe, it will, it will glow and it will emit light like this. So that's the three things. It needs to have a power supply, so mine's a battery, connecting wires, and a load, which in my instance is a light. And my circuit's actually also got something else here. So it's actually also got a switch, and that just means that I can turn my electric circuit on or off, because electricity will not flow around a circuit unless the circuit is complete. So one side of the battery is electrons are able to flow from one side of the battery all the way around to the other side of the battery. And when my switch is closed, that will enable electrons to flow all the way around. Now in my picture here, imagine if I want to tell scientists around the world that I have this great electric circuit here. It's got a light globe and a battery and a switch, and I can turn it on and turn it off and make the globe turn on and off. But I'd have to draw them some sort of diagram. And if I was to try and draw this exact diagram here, I'm not a great drawer, as I'm sure you can tell, it wouldn't be very easy to understand. So instead, scientists have a series of electric circuit symbols. And I've got some of these down here. So electric circuit symbols, they're the same around the world. Connecting wire is one of them, and that is just a straight line. A globe, instead of trying to draw a picture of a globe, what we have here is a connecting wire and then a little bit of a lump, and then more connecting wire, and then that that bump has got a circle around it. So that's a globe. Batteries or cells of batteries are these two, a big line and a little line. Switches is a line with a dot, another dot here. This is the open switch, and then the connecting wire continues along. You can see there's a whole bunch of symbols here: electric motors, ammeter, a voltmeter, different types of resistors here. So if I was going to draw my fantastic electric circuit here, well, I've got certainly I've got a battery, so I'm going to draw my battery like this, and I'm going to draw some connecting wires, and I've also got in my circuit, I've got a light globe, so that's my light globe, and I've also got in my electric circuit, I've also got a switch. At the moment in that picture, the switch is open, so electricity is not flowing through, so I'm going to draw my switch as an open switch, and then I must have my circuit complete. So wires must go from the start of the battery all the way through to the end of the battery here. So I've got a battery, light globe, and a switch. And that's my electric circuit. And you can see that using circuit symbols, it's way easier to draw electric circuit diagrams. And so that is what scientists do all around the world.